Poor neighborhoods nestling on the hills are a common sight around Guatemala City. The sun shines on the residents nearly all year round, but daily lives are a struggle for survival. Those who can afford a bit of style come to this tiny hairdressing salon. Yadira Nohema Rodan is lucky to have a business of her own in order to make both ends meet. Money is hard to come by, but even that is not the biggest problem. Her 15-month-old son Sergio will never develop normally, physically or intellectually.
In the hospital they gave me the diagnosis. They took a blood sample and confirmed the illness. They told me it was hypothyroidism.
This deficiency of the thyroid gland, called hypothyroidism, is treatable if a baby undergoes a screening test within 72 hours of birth. Sampling only 2 drops of blood from the baby's heel helps to check hormones produced by the thyroid gland that are vital for many of the body's functions, including mental health. This preventive technology, supported by the International Atomic Energy Agency, allows hospitals to detect hormonal disorders in babies at an early stage.
It can diagnose fairly early hormonal disturbances that can occur in newborns, and the subsequent problems of this illness can cause hypothyroidism.
Guatemala is arriving at an ambitious program to screen all newborns for this debilitating illness. If detected and treated early, a child can grow up healthy.
And if you start treatment within the first month of its life, this child will be healthy for the rest of its life.
The benefits of early screening and treatment of a child with hypothyroidism are enormous. It is 2 drops of blood that can save an ocean of tears. Radiation therapy is an extremely precise business. A mistake could be lethal or render the treatment ineffective. Too much radiation may destroy the patient, and too little may not wipe out the cancer cells. People whose profession is to ensure that the dose is always the right one are behind the scenes. Ángel Osorio heads the dosimetry laboratory at the Ministry of Energy of Guatemala.
In Guatemala, I completed my further education at the local university. I got my degree, and then, with the sponsorship of the International Atomic Energy Agency, I was in Venezuela to get a master's degree in medical physics.
As a medical physicist, he combines the knowledge of medicine and physics to calibrate dosimeters that are used to measure the intensity produced by radiation therapy machines. Obviously, one cannot make these measurements on a patient, so the work is done on a phantom, which is a tank filled with water, as the human body is more than 80% water. The services of a well-kept dosimetry laboratory may go beyond the borders of one country. The International Atomic Energy Agency, which leads the efforts in technical cooperation, strives to turn institutions in member countries into regional centers of excellence.
Actually, we are in a position to provide services to the whole Central American region, and we have been able to provide services to El Salvador, Nicaragua, Costa Rica, and the Dominican Republic. But in reality, we are ready to provide services to any country in the region. I would hope we would be able to extend our services, because the demand is growing. We have an installed capacity which so far has not been fully exploited. For instance, in X-ray quality control and X-ray calibration. We have more capacity, and it would be delightful to be able to expand.
Part of the daily routine for Ángel is visiting hospitals with radiation facilities, where he literally goes to the source and prepares to check the radiotherapy machine. A physician prescribing medication for a patient may say, take 1 or 2 tablets per day. There is no way for the radiation treatment to have that liberty. A machine must be calibrated to deliver the right amount of dose, no less, no more. Ángel Osorio sees to it that the dose is delivered to the right target and in the right amount. Central Costa Rica is a sprawling valley which in the past provided drinking water from its rivers and springs. Today, surface water is so polluted that the rivers are so sight even to look at, particularly in the urban areas. Dr. Jenny Reynolds, lecturer at the Costa Rica National University and the head of its environmental hydrology laboratory, began to probe the state of the valley's water supply more than 10 years ago.
Well, I realized that the population of Costa Rica will increasingly need more water. Previously, the main source of water for public supplies was surface water, that is, river water. But since the rivers have been becoming contaminated with time, especially in the lower parts of the drainage areas and in the cities, groundwater has begun to take on increasing importance.
The people of the region switched to the water in the aquifers beneath their feet. In the metropolitan region of the Central Valley, groundwater now sustains more than 1 million Costa Ricans. However, the residents would be better off with groundwater only if it were clean. Coffee plantations, which in the past were the pride and the money of the country, had used too many fertilizers that seeped into the groundwater. When Dr. Reynolds began her quest for clean groundwater, she started to use isotope hydrology, a nuclear technique that is capable of identifying harmful substances even in minute quantities.
First of all, we started to evaluate the nitrate concentrations in groundwater, and we realized that there was an increase over time in these concentrations. Then, using isotopes, we were able to identify the sources, namely nitrogen fertilizers used on coffee plantations.
The IAEA continues to be an active partner in the Costa Rican process. Costly isotopic analysis of water samples is undertaken without charge by a regional laboratory supported by the Vienna-based agency.
The International Atomic Energy Agency provides funds for purchasing equipment and also for training, both for university people and for other participants working in government institutions, and it also sends experts to provide advice in certain areas.
Isotope hydrology for Dr. Reynolds is not an end in itself, but a means to raise public awareness about Costa Rica's water woes. Armed with the scientific knowledge, she and her team work closely with the local communities establishing vulnerable areas.
I think that in a country as small as Costa Rica, a person may be a scientist or have a scientific training, which is necessary to handle information and design a project, but must also make known the results and give recommendations for the integrated and sustainable management of water resources.